In this video, we're going to cover exhaustive events. Again, let's do this with an example. Let's roll a die, and this is our sample space. 1, 2, 3, 4, 5, and 6. Let's put the sample space down. This is our sample space, and these are our sample points. 1, 2, 3, 4, 5, and 6. Okay. Now let's get some events. I'm going to write down 4 events here. Let's say our event A is 1, 3, and 5. So whenever one of these occur, event A has occurred. And if you want to plot event A, this is what we get, 1, 3, and 5. Then we have event B, which is 2 and 3. So this is our event B. Event C is 2 and 4, 2 and 4. And event D is 5 and 6. So that's 5 and 6. So now let's do something interesting. Let's do an experiment. Let's throw a die. Well, what can we say about this outcome? Well, it could be anything from 1, 2, 3, 4, 5, and 6. It can't be anything else. It can never be outside the sample space. But as we can see that all 4 of these events have together covered the entire sample space. Some event is covering some number. And together they're covering all the numbers. So can we say that whenever we throw the die, at least one of them will necessarily occur? Let's do an example. Let's say we throw the die and we get a 6. Well, when we get a 6, the event D has occurred. What about 3? When we get a 3, the event B has occurred and the event A has occurred. When we get a 4, the event C has occurred, and so on. No matter what you get, one of these events will definitely occur, will necessarily occur. And we can say this with confidence because together they cover everything possible. And in set notation, that's how we write it. We can say that A union B union C union D, which is the union of all 4 of these sets, is the entire sample space. This is what we mean by exhaustive events. And the word exhaustive, that's here because together all 4 of them have exhausted the entire sample space. They've exhausted all possible options. So that's what we mean by exhaustive events. Okay, let's look at the formal definition. This is our sample space, and let's say we put in some events. This is one of them, this is another one, this is one more. Let's do one more. So together they're covering the entire sample space possible. Okay, here's a patch left. So let's add one more event here. So now together they're covering the entire sample space. All of these events have exhausted the entire sample space, which means they are exhaustive events. And this is what you'll see in your textbooks. These events E1, E2, E3, E4 and so on are exhaustive if at least one of them necessarily occurs whenever the experiment is performed. In other words, together they cover or exhaust the entire sample space. So that's the definition of exhaustive events. Sometimes exhaustive events are confused with mutually exclusive events. That's something that we have covered in the previous video. And now let's pay attention to the difference between the two. Exhaustive events have to do with teamwork. Together, they cover the entire sample space. They're not competing against each other. They're saying that, okay, let's team up and let's cover the entire sample space. If we can do that, will be exhaustive events. Mutually exclusive events are fighting against each other. When one of them happens, the other one never happens. They don't have anything to do with the entire sample space. They're saying that, okay, if this event 1, 3, if this event happens, this other event 4, 6, this can never happen. They're exclusive to each other. If one of them happens, it excludes the other one from happening, which means they are mutually exclusive events. So this is the basic difference between exhaustive and mutually exclusive events. I'll write this down again. Together they cover the entire sample space, they're exhaustive events, and for mutually exclusive, they cannot occur simultaneously. That's what we have to look. If they're occurring simultaneously, they're not mutually exclusive. And now you might be thinking, but can events be both mutually exclusive and exhaustive? In fact, that's the question that we'll cover next. Can events be mutually exclusive and exhaustive? Let's do this with an example. Let's say this is our sample space, and we have 1, 2, 3, 4, 5, and 6. These are our sample points. Let's get some events going on. Event A is 1 and 3. This is our event A. Event B is 2 and 3. Event C is 2 and 4. and event D is 5 and 6. And you can pause the video and test your own understanding. Figure out which of these events are mutually exclusive, which of them are exhaustive, and then finally we'll discuss which of these events are both mutually exclusive and exhaustive. Okay, let's take them one by one. Events A and B, that's yellow and green region, well, they overlap, they're not mutually exclusive. What about event A and C, yellow and orange? Well, they don't overlap, 1 and 3 and 2 and 4. So A and C are mutually exclusive. What about A and D, the yellow and pink region? Well, they're also mutually exclusive, there is no overlap. What about B and C, green and orange? Well, they also overlap, so they're not mutually exclusive. What about B and D, green and pink? Well, they don't overlap, so they're mutually exclusive. What about C and D, orange and pink? 2 and 4 and 5 and 6. No overlap, which means they're mutually exclusive. So I think this covers all the pairs of mutually exclusive events. Let's take them together. Let's think about exhaustive events. Are all 4 of them exhaustive? Think about it. Yes, all 4 of them are exhaustive because together they cover the entire sample space, which means A, B, C and D combined, they're exhaustive events. But are they mutually exclusive and exhaustive? Well, no, because there is some overlap. Look at this green event, event B. This is overlapping with this yellow event, event A, and the orange event, event C. So I think this green is causing some problems. If we get rid of the green event, now let's look at it. Event A, event C, and event D. They're not overlapping, so they are mutually exclusive. And together, they're working as a team. Together, they're covering the entire sample space, which means these 3 events are both mutually exclusive and exhaustive. I hope this example helped you figure out the difference between exclusive and exhaustive events, and also help you figure out which events are both mutually exclusive and exhaustive.